Okay, so welcome back. We're in chapter 21 of Mishkin's Money and Banking text, and this is going to be a really short lecture, and we're going to look specifically at the MP curve, which tells us in a very simplistic way how monetary policy operates. And so the point of this chapter really is, again, to think about an easy way to characterize monetary policy. And so we do that through the so-called MP curve or monetary policy curve. And what we'll see later is that it looks a lot like a more sophisticated Taylor rule type of setup. And so this is a more simplified sort of Taylor rule, if you will. But the idea here is this is just a basic representation of Fed policy and how the central bank might respond to economic conditions, and in particular, how it might respond to inflation. And so we characterize this simple MP curve through this expression right here. So this tells us how the real interest rate, which that's the thing that actually impacts the real economy, behaves according to a couple of things. So on the one hand, we have this component right there, which we have the inflation rate multiplied lambda. So that lambda thing represents really how responsive the central bank is to changes in the inflation rate. And so intuitively, you can think of a higher lambda, meaning that the central bank is going to be more of an inflation fighter or an inflation hawk, if you will. Again, if inflation goes up, as lambda is higher, then that's going to result in a much higher increase in the real interest rate, which, as we have talked about in the past, means that it's going to be contractionary to the economy to try to push inflation back down. And so it turns out that for that reason, the lambda parameter there should be greater than 0. And what that means is that if that lambda parameter is greater than 0, that's going to result in the so-called Taylor principle applying, okay? And basically what that means is two things. Number one, our MP curve is going to be upward sloping. But number two, it means that monetary policy is going to be stabilizing to inflation. And we'll talk more about that, exactly what that means in a second. But essentially, monetary policy is going to be responsive enough to be able to raise real rates as inflation goes up to try to push inflation back down. So this, as I said, this lambda pi term, the idea here is that this is the response that central banks have to adjustments in the inflation rate. Now we want to be a little bit more specific here because it's in adjustments to or changes to the current inflation rate. So as the current inflation rate changes, the Fed is sort of going to automatically be adjusting its monetary policy response in order to address inflation, okay? So it's automatic in the sense that the Fed sort of has this mechanical view of how to deal with the current inflation rate. And I'll talk about that and how what that really means in regards to other factors here in just a second. But the intuition here is simply that, well, if inflation increases, then the Fed is going to sort of automatically kick into gear and conduct open market operations. That's the typical way in which they would adjust monetary policy. And in previous chapters, we looked at the market for reserves and saw how open market operations can influence the short-term interest rate, in this case, the Fed funds rate, right? And so the idea then is that the Fed wants to conduct open market operations to try to raise the short-term interest rate or the Fed funds rate. And somehow the Fed then is going to, through that increase in nominal interest rates, is going to impact the real interest rate. And so the kicker here is that it's got to be the case that the nominal interest rate responds more than 1-for-1 to impact the real interest rate, right? So again, the idea here, and this gets back to the Taylor principle, is such that if inflation goes up 1 percentage points, it's got to be the case that monetary policy operates in such a way to raise the nominal interest rate more than 1% so that the real interest rate rises. Because remember, the real interest rate is the difference between the nominal interest rate and the inflation rate, okay? So in order to push the real rate up, if inflation goes up 1%, the nominal interest rate has to go up by more than 1% in order to push the real rate up. So in order for policy to be stabilizing, the nominal interest rate has to move more than 1-for-1 to changes in the inflation rate. So our MP curve in this simple framework, oops, that's a plus, sorry about that, looks like the following. Again, as the current inflation rate varies, we're just going to be moving up and down along this MP curve, okay? And we'll see what is going to shift this momentarily. But you can see here that this lambda parameter is equal to 1/2. So as inflation goes up by 1%, the real rate is going to rise, and therefore that's going to be stabilizing to inflation here. So the other part of the story here in the MP curve is this so-called autonomous policy parameter, R bar. And so the idea here is that R bar is going to be changes in monetary policy which are designed to impact the economy or because of changes in economic conditions other than simply changes in the current inflation rate. And so the changes in the autonomous policy parameter here are going to act like shifts of the MP curve. And so as an example, if we wanted to conduct a so-called autonomous tightening of monetary policy, that's going to be an increase in that R bar parameter. So even if inflation is holding steady right now, policymakers might decide that they want to increase this autonomous policy parameter and create this tightening effect. Why is that? Well, there's a couple reasons why. First of all, even if inflation is stable today, if inflation expectations are looking to be high in the future, the Fed wants to be proactive because policy works with a lag. So they may decide to tighten policy today to try to take care of expected inflation problems tomorrow. Alternatively, it could be things like asset price bubbles or other things like that that could be bubbling up that the Fed might be worried about. Alternatively, we could conduct an autonomous policy easing. So that's just when the R bar parameter decreases, okay? And so again, there's several reasons why this could be. For one thing, the Fed might be worried that the economy is going to go into a recession later on. So again, if they're forecasting ahead and thinking about what monetary policy should be doing, and they should be thinking ahead because policy typically works with a lag, then they're going to reduce that R bar parameter in anticipation of weakness in the economy in the future. And again, that's independent of what the current inflation rate is. And so one thing to underscore here that's really important is if we think about, for instance, as I explained before, changes in expected future inflation can result in a shift of that MP curve, right? As I explained before, if we expect inflation to be high in the future, the Fed wants to be proactive about that to try to stabilize inflation and bring it back down. So R bar could increase even if inflation is still stable today at this point. Alternatively, if we have changes in the current inflation rate, as I said before, the Fed acts in this sort of mechanical way to address the current inflation rate and adjust its policy stance appropriately based upon this MP curve. So changes in the current inflation rate simply move us along a given MP curve. So visually, you can see some examples here. Here we have this autonomous tightening of policy. So that MP curve shifts up when R bar goes up, and that's, as I said, a tightening. And alternatively, we have this autonomous easing policy where we move to the MP3 curve, and so that means that interest rates are falling, holding inflation constant. And so because of that, cost of borrowing is easier, and so that would be an expansionary type of policy. Thank you.